lower, then we're gonna be having these three problems. Now, people suggested doing geometry and linear algebra in the comments. I think I will do that on the next week. Okay, so let's begin with solving. We have this function, f capital of x is equal to this integral, and we have to show that it's not bounded on this interval. Now, that would be true if integral of a function that is lesser on this interval is also not bounded. So let's find such function. Let's begin by defining f tiny of t as 1 over natural logarithm of t. Now we need to find a function that would be lesser on this interval, g of t. An intuitive pick would be 1 over t. It's easy to show that it is in fact lesser than 1 over natural logarithm of t on this interval. So g of t less than or equal to f of t for t greater than or equal to 2. Now we can take the definite integral of both sides. We're gonna get natural logarithm of x over 2 as less than or equal to f capital of x. X is greater than or equal to 2. This is true according to the comparison theorem. Now we just need to show that natural logarithm of x over 2 is unbounded. As being by saying that natural logarithm of x over 2 is equal to some number m. And let's say that m is greater than 1. Let's exponentiate both sides. We have x equals 2 times e to the power of m. And now we know that this function will take the value m on this x that actually lies on this interval. In other words, this function is unbounded. If it's unbounded and also less than this function, then it's gonna be unbounded too. Okay, let's continue. We have this problem. We need to prove that f is bounded on this interval if f capital over natural logarithm of x is bounded on the same interval. Let's begin by assuming that f of x is bounded. Let's write it as f of t. Instead, it's easier to deal with. It's less than or equal to some number a that bounds it. Since it's not decreasing, we don't have to include the modulus, absolute value. Okay, now let's divide both sides by t, knowing that t is greater than or equal to 1. We're working on another interval. That's not gonna import this too much. Less than or equal to a over t. So now we can take the definite integral of both sides with respect to t. That's just gonna be f of x is less than or equal to a times natural logarithm of x. I don't need to include the absolute value because we're working on the interval x is greater than or equal to 1. So now we're going to divide both sides by natural logarithm of x. And it's going to be less than or equal to a. Now, this in turn is supposed to mean that the f of x is bounded by a is something implied by f tiny being bounded. So we have proved that. Let's continue to this problem right here. First part is easy. We're just differentiating both sides. We get f of x equals e of x. Easy. No problem. Now, the second part is more interesting. If we were to differentiate both sides, we'd have to differentiate them with respect to x squared. So we have f of x squared is minus 2 times e to the power of 2 times x squared. And now we need to find the original function somehow. Now, this definition of the function over here defines it only for the positive values. So for the negative values, the only condition is that it has to be continuous. Let's say we have some number t equals x squared greater than or equal to 0 for obvious reasons, because we're working with the real value functions. And that would mean that f of t is equal to negative 2 times e to the power of 2t. Cool. Now, this is, again, defined only for t greater than or equal to 0. So let's finally have a proper definition for f of x on the set of all real numbers. We're gonna define it as a piecewise function. It's gonna be negative 2 times e to the power of 2x for x greater than or equal to 0. Now, for it to be continuous, the part for x less than 0 is supposed to be equal to this part for 0 too. So let's say that this is some function g of x, and g of x is a function that has to equal to this function on 0. So g of 0 is going to be just minus 2. And g is continuous. Cool. Now, this entire thing is supposed to be the general solution for this problem. I would assume that they probably, most likely, meant that we should just take this function and call it a day. But I think this is supposed to be the correct solution. It's a piecewise function. We can take literally any continuous function that has a g of 0 as minus 2. So we have solved these problems, 3 in total. That's it for today, yeah? Bye, yeah?